Experiment-2. Aim of the experiment. The objective of this experiment is to determine and identify the unknown salt provided by observing the effects of heat on the salt. The unknown salt can be any of the following: copper carbonate, zinc carbonate, washing soda, copper sulfate crystals, zinc nitrate, copper nitrate, lead nitrate, ammonium chloride, iodine, ammonium dichromate. Theory. When a salt is heated, it undergoes decomposition, resulting in various changes such as color alteration, gas evolution, or release of water vapor. By observing these changes, it is possible to identify the anions and cations present in the salt based on the evolved gases and the residue formed respectively. Apparatus and chemicals. The apparatus required for this experiment includes test tubes, a test tube holder, a Bunsen burner, and the unknown salt. Procedure. 1. Take a small amount of the given salt and place it in a clean and dry test tube. 2. Hold the test tube at an angle using a test tube holder and position it over the flame of a Bunsen burner. 3. Gently heat the salt and then increase the heat intensity. 4. Observe and record the changes occurring in the salt according to the provided table. Serial number. Experiment. Observations. Inference. 1. To perform the experiment, take a small amount of the provided light green powder and place it in a dry test tube. The salt undergoes a color change to black when strongly heated. It produces a colorless and odorless gas during this process, which has the ability to turn freshly prepared lime water milky. The unknown salt is a light green powder, specifically copper carbonate. When heated, the salt decomposes and releases a gas, which is identified as carbon dioxide. 2. To conduct the experiment, take a small amount of the provided white powder and place it in a dry test tube. The salt undergoes a transformation into a pale yellow color when strongly heated. It releases a colorless and odorless gas, which has the properties of extinguishing a glowing wooden splinter and causing freshly prepared lime water to turn milky. Upon cooling, the residue left behind changes to a white color. The unidentified white powder is zinc carbonate. Upon heating, the zinc carbonate decomposes, releasing a gas that is identified as carbon dioxide. 3. To carry out the experiment, take a small amount of the given white flakes and place them in a dry test tube. Upon strong heating, the salt undergoes a series of transformations. It first swells, then melts, and eventually gives off steamy vapors. These vapors are colorless and odorless. As the vapors rise and come into contact with the cooler parts of the test tube, they condense and form tiny droplets of colorless liquid. This liquid has the ability to turn white anhydrous copper sulfate to blue copper sulfate pentahydrate. When the system cools down, a white amorphous residue is left behind. The provided salt is washing soda, specifically sodium carbonate decahydrate. When heated, the salt undergoes decomposition, resulting in the liberation of water vapor. 4. To proceed with the experiment, place a few blue crystals in a dry test tube and apply heat to them. Upon strong heating, the crystals undergo a transformation into a white amorphous powder. This process is accompanied by the liberation of steamy vapors. These vapors rise and condense on the cooler parts of the test tube, forming a colorless liquid. The blue crystals correspond to hydrated copper sulfate, specifically copper sulfate pentahydrate. When heated, the crystals lose their water molecules, and the resulting colorless liquid is identified as water. 5. To perform the experiment, take a small amount, pinch, of the provided white crystalline solid and place it in a dry test tube. Then, apply heat to the test tube containing the salt. Upon strong heating, the salt melts and forms a white sticky mass. During this process, steam vapor is liberated. These steamy vapors then condense on the cooler parts of the test tube, forming tiny droplets of colorless liquid. This liquid has the ability to turn anhydrous copper sulfate blue. Furthermore, when the salt is strongly heated, reddish-brown fumes are liberated. These fumes can turn freshly prepared ferrous sulfate solution black and rekindle a glowing wooden splinter. The residue left behind after heating is pale yellow while hot, but it becomes white upon cooling. The crystals provided are zinc nitrate, specifically zinc nitrate hexahydrate, which is Zn. When heated, the crystals lose their water molecules and the resulting colorless liquid is identified as water. The gases liberated during the heating process are nitrogen dioxide and oxygen. Additionally, zinc oxide formed from the decomposition of zinc nitrate exhibits a pale yellow color when hot and turns white when cooled. 6. To conduct the experiment, place a few bluish-green crystals in a dry test tube and apply heat to them. Upon strong heating, the crystals undergo melting, forming a bluish-green mass. This process is accompanied by the liberation of steamy vapors. These steam vapors then condense on the cooler parts of the test tube, resulting in the formation of a colorless liquid. When this liquid comes into contact with anhydrous copper sulfate, it turns blue. Continuing the heating process, the bluish-green mass further transforms and changes into a black residue. The blue crystals are composed of copper nitrate, specifically copper nitrate hexahydrate. When heated, the crystals undergo a decomposition reaction, releasing water molecules. The resulting colorless liquid is identified as water. 7. To conduct the experiment, take a small amount of the provided white crystalline solid and place it in a dry test tube. Then, apply heat to the test tube containing the salt. Upon strong heating, the salt crumbles and produces a crackling noise. This process is accompanied by the liberation of a reddish-brown gas with a pungent smell. The gas has the ability to turn freshly prepared ferrous sulfate solution black and can rekindle a glowing wooden splinter. After the heating process, a reddish-brown residue is left behind. When hot, the residue appears reddish-brown, but upon cooling, it changes to a yellow color. The white crystalline solid provided is lead nitrate Pb. Upon heating, the lead nitrate decomposes, liberating gases including nitrogen dioxide and oxygen. The residue left behind after heating, which appears reddish-brown when hot, is identified as lead oxide. 8. To perform the experiment, take a small amount of the given white crystalline solid and place it in a dry test tube. Apply heat to the test tube containing the salt to observe any changes or reactions. Upon strong heating, the salt undergoes decomposition and liberates a colorless gas with a choking smell. This gas has the property of turning blue litmus paper red. Additionally, a white sublimate forms on the cooler parts of the test tube due to the condensation of the gas. With further heating, the entire substance sublimes, meaning it transitions directly from a solid to a gaseous state without leaving any residue behind. The given solid is ammonium chloride. When heated, it undergoes sublimation, meaning it directly converts from a solid to a gas without passing through a liquid phase. The gas liberated during this process has a choking smell and is identified as ammonia gas. The sublimate that forms on the walls of the test tube is composed of hydrochloric acid gas. 9. To conduct the experiment, place a few violet crystals in a dry test tube and apply heat to them. Observe any changes or reactions that occur during the heating process. Upon heating, the crystals undergo sublimation, directly transitioning from a solid to a gaseous state, forming violet vapor. This violet vapor condenses on the cooler parts of the test tube, resulting in the formation of a sublimate. The gas produced has the ability to turn moist starch paper blue. The provided crystals are composed of iodine. When heated, iodine undergoes sublimation, transitioning directly from a solid to a gas phase. The gas liberated during this process is identified as iodine gas. 10. To proceed with the experiment, take a small amount of the provided orange-red crystalline solid and place it in a dry test tube. Apply heat to the test tube containing the salt and observe any changes or reactions that occur during the heating process. Upon strong heating, the salt swells and releases steamy fumes. These fumes then condense on the cooler parts of the test tube, forming droplets of colorless liquid. This liquid has the property of turning anhydrous copper sulfate blue. Simultaneously, a colorless and odorless gas is liberated during the heating process. This gas is neither combustible nor a supporter of combustion. It does not react with lime water to produce a milky appearance. After the heating, a greenish-gray residue remains in the test tube. The orange-red crystalline solid given is ammonium dichromate. When heated, it decomposes into various products. The colorless liquid observed on the cooler parts of the test tube is water. The gas liberated during the decomposition is nitrogen gas. The greenish residue left behind is chromium oxide. Precautions. Always work under supervision. Ensure that a knowledgeable person is present to guide and assist you throughout the experiment. Wear a lab coat or protective clothing while working in the laboratory to protect yourself from any potential hazards. Handle chemicals with care, as they can cause burns or other injuries. Follow proper safety protocols when dealing with hazardous substances. Avoid directly inhaling the liberated gases or fumes, as they can be harmful. Make sure to work in a well-ventilated area or use appropriate protective equipment, such as a fume hood. Handle glassware carefully to avoid breakage. Immediately report any damages or accidents involving glassware to the supervisor. When heating test tubes or substances, always use a test tube holder to hold the test tube. Maintain a safe distance between yourself and the flame of the burner to prevent burns or accidents. Exercise caution when heating the test tube. Avoid overheating, as it can cause the test tube to break or shatter. Take care when exposing the gas to a burning wooden splinter, as the reaction can be explosive. Follow proper safety procedures and keep a safe distance. Remember that many gases are colorless, odorless, and neutral towards litmus paper. Perform confirmatory tests to accurately identify the gas and avoid relying solely on preliminary test results.